Okay, so our new lesson today is on medians and altitudes of triangles. If you want to take notes along with me, we're going to first just get definitions down. A median of a triangle. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So let's write that first. A segment from a vertex, of course, vertex of the triangle, to the midpoint of the opposite side. Okay, so now that we have the definition, let's draw a picture and see what it looks like. So I'm going to draw just a plain old ordinary scalene triangle, and we're going to take any vertex. Let's say we start at this vertex, and we're going to connect that with a segment to the midpoint of the opposite side. So when I do it, I'm clearly visually going to try to put it in the middle, and of course I'm going to put in some tick marks to show that I want that to be exactly the middle. So what we would say, here we would say that segment AD is a median of triangle ABC. Segment AD is a median of triangle ABC. Another way to say it is that segment AD is a median to segment BC, but when you're writing it down, you don't have to write the of or the to. Okay, so let's go to an altitude. So an altitude is also a segment in the triangle. It's from the vertex, but instead of going to the midpoint, it is perpendicular to the opposite side. So we're going to write that it's a segment from a vertex, which is perpendicular to the opposite side. Okay, and if I sketch this one, I'm going to try to draw approximately the same scalene triangle so that you can see, excuse me, so that you can see the difference. And so instead of drawing my segment to the midpoint, I want to drop a perpendicular. So it literally has to be form a right angle with the opposite side. So that's going to look more like this. And we're going to go ahead and name it the same thing. And here you would say that segment AD is an altitude, and you can abbreviate altitude, ALT, of triangle ABC, or AD is an altitude to side BC. Notice that we don't abbreviate median, but you can abbreviate altitude. Okay, the last thing I just want to show you is a proof. And so here's an interesting thing. I think I'm going to start with a new sheet of paper because it's a rather long proof. One of the things that's introduced in this lesson is the idea of you setting up the proof yourself. So a problem might be prove that the altitude to the base of an isosceles triangle is a median. Let's write that down. Prove that the altitude to the base of an isosceles triangle is a median. Now, that's not to say that you have to write this down when you're doing these problems in your homework or for practice, but for the sake of these notes, I wanted you to see what the problem was. So that would be a problem in your book now. It'll say, prove that the altitude to the base of an isosceles triangle is a median. And that word prove tells you that you have to write a 2-column proof. And so you're going to set it up yourself. You have to use exactly what's given in here. So I hear isosceles triangle. So I'm going to draw an isosceles triangle. I'm going to try to make it look isosceles and not equilateral. I'm also going to label the points, and I really would, it would be easier on Miss Siski and I if you would, use the most common letters. So start with the beginning of the alphabet and go through there. Now it says prove that the altitude is a median. So what you're given is the altitude, and what you're proving is the median. So I'm going to go ahead and sketch an altitude And now we also have to come up with the given and the prove information. So you're given, you have to tell the reader that you're given triangle ABC is isosceles, and we know that you cannot just stop there. You have to tell the reader what the vertex angle is, or I like to always say with base. So triangle ABC is isosceles with base BC. Okay, I see that I've forgotten to name that other point. And also, you have to tell the reader that segment AD is an altitude of triangle ABC. And what we're going to be proving is the median. So we're going to prove that segment AD is the median of triangle ABC. So this is new and something that you should be expected to be able to do on tests and quizzes as well. Not all the time, but that's part of what we're learning here this year. So we're going to go ahead and set up our 2-column proof. Okay, so as you know, you get a point just for copying down the given. Now let's talk through this. I'm going to think about it backwards. I might not have to do a flow proof, but I'm going to think about it backwards. In order to say median, I would really like to know that segment BD is congruent to segment DC. I can't mark that because I don't know that yet. We've done a lot with proving congruent triangles, and if I had congruent triangles, then by CPCTC, I would have those segments, and then I'd be done. So let's see if we can do that. I have right angles. It's isosceles, so I would be able to say that. And so with my right triangles, I have hypotenuses, and look at that, I could do reflexive property. So I think I can do HL and do this. Let's just get all that down. So just because it says isosceles, it doesn't mean you don't have to say the segments are congruent, unless that's the piece that they give you here. So AB is congruent to AC, and that would be by the definition of an isosceles triangle. And of course we have reflexive property, so AD is congruent to AD by the reflexive property. And then I have the tick mark here for my, to help me visually, but I haven't said right angles. And so just because it says altitude doesn't mean I have right angles. It does mean that I can say right angles. So I'm going to say angle ADB is congruent, no, angle ADB and angle ADC are right angles. And that would be by, and this is new, by definition of an altitude. And I think at this point we're going to let you not have to write the if-then. Thank you, Mrs. Trace and Mrs. Siski. I'll have to talk with Mrs. Siski and confirm that. So now we have hypotenuses, legs, and right angles. So we can say the triangles are congruent. If I'm going to say triangle ABD, you're going to be careful to name the other triangle correctly. If I started with A and went to B and then D, I better start with A and go to CD. So triangle ACD. This is by HL. I still need to put 3 numbers in parentheses. So I have hypotenuses, I have legs, and I have right angles. And those can be in any order, but you need to have them listed. Now, as we discussed, we're going to go ahead and use CPCTC to get what we need. BD is congruent to DC by CPCTC. Terrific. That's normally where we stop. But we're not done because our proof statement is the median. Now that we have BD congruent to DC, now I can say it's a midpoint, it's a median. You don't have to state midpoint first. You can go right from congruent segments to median. So I'm going to say that AD is a median of triangle ABC, and the reason is definition of median. And again, definitions are reversible. So you can be given an altitude and you get right angles. That's a definition. You can be given right angles and get an altitude. And so in this case, we're given congruent segments and you can get a median. All right, that's all for now. You'll learn about concurrency in the next video.